So angle A is obtained next using Napier's rule, and this angle A helps us to find out our initial course. So angle A is used to find out our initial course, exactly like we did in normal great circle sailing questions, following the 1 2 3 method, 1 2 3 stepwise procedure. We have distance AV1, we have distance BV1. Adding them gives us the total composite distance between A to B, and initial course has been obtained using angle A already. So this gives us all the required items for this typical problem. Important thing to remember here is you have to make the diagram, and out of the two triangles, first identify which is the spherical triangle. Any one of them could be the spherical triangle depending upon to which place the limiting latitude coincides. So once you have the spherical triangle, then first thing which we find is the longitude of the vertex. Once the longitude of the vertex is known, everything else falls into place. We can calculate the rumb line distance, we can calculate the initial course, the GC track distance, and the question gets solved. So this was a typical problem which sometime appears in the exam, and the method how to tackle it.
Sir, in this case, what will be the final course?
090.
You will not take
090,
side
yeah.
like you were taking before, the shift side and from the mock to how you were doing.
No, beta. In this case, the final course, as these candidates said, 090 is correct. So you don't need to calculate the final course here, because when you are moving on a rumb line on a parallel track, so the course will be exactly 090, and if you are moving west, it will be exactly 270. So in this case, course 090.
So I have one doubt here.
Bolo beta.
So can you just minimize this black screen? I want to show on the diagram for that. Yeah.
No, I didn't get you, beta.
Sir, the diagram is hidden, sir, behind the black screen.
Okay.
Yeah. Sir, what if this triangle PAV1 was on the opposite side? If it was PV1B, then initial course will be 090, right? And then the final course we'll have to calculate, right? If the
That's
same
right,
triangle
beta.
was on the other side.
That's right, beta. That's right. Okay, so any more doubt coming, beta? Very good. That's great.
Sir, since we are finding this, if we find this small angle P green one, and then we have the D long between A and B already, and we can calculate the P2, and then we can solve directly with the this cost lat departure upon D long formula.
That's right, beta. You can do
How
that.
can you calculate?
Yeah, thank you.
It's a rumb line, sir. How can we calculate between triangle PAB?
No, beta. No, that's okay. What he was saying is, instead of getting the longitude of vertex 1, just get this angle P here.
Okay.
Bravo Papa Victor 1. So that can be done, beta.
Okay.
Okay, let's move ahead then. Now, having understood this kind of a question, we will now proceed ahead. Now, in composite sailing questions, you may sometimes get stuck with a challenge in the question, and you may not be able to find out how to proceed ahead in that case. Now, that challenge is, let's assume that you have solved the triangle PAV1 using the Napier's rule, and you have found out the longitude of the vertex, the V1. Now when you find out the longitude of the vertex, there is a possibility that the vertex V1 may go outside the triangle PAB, Papa Alpha Bravo. So how will you come to know that? We have the initial position and the final position known to us. Both the longitudes are known to us. And we have calculated the longitude of the vertex V1 using the Napier's rule. So when you compare the longitude of V1 with the longitude of your final position, it will immediately tell you whether V1 lies in between A and B or V1 lies outside A and B. Let's say, for example, if A's longitude was 30 degrees east and B's longitude was 70 degrees east, and you find out that the longitude of vertex 1 is 80 degrees east. Now obviously 80 degrees east has to be more eastwards of the destination. So how to proceed ahead in this case, and what does this mean? If the vertex comes outside, that basically tells you that from your initial position, if you move on a track which has its vertex on the limiting latitude, you will be reaching at a place farther away from your destination position. So this simply means that if you follow a great circle track from A to B, then in no case the vertex is going to come in between A and B. The vertex will not be inside. The vertex is going to be outside. If the vertex is going to be outside, that tells us that while going from A to B, the vertex is outside. So while going from A to B, we will never be crossing the limiting latitude. You see, the vertex which we have found out has come outside the triangle. So this tells us that if you move within this triangle PAB, the vertex being outside, you are not going to cross the limiting latitude in any case. So if you get a solution like this, that the vertex is falling outside the triangle, then in that case you have to simply write a remark. Since the vertex falls outside the triangle, it is clear from the working that if we move on a great circle track from A to B, we will never be crossing the limiting latitude. So composite sailing is not required here. And after writing this remark, you can make this PAB triangle again, and you can solve it using the great circle method, using the cosine formula, and you can find out the great circle distance. So in that case, composite sailing is not required at all. So going on a GC track, you will never cross the limiting latitude. So we follow the GC track from A to B and calculate the GC distance. However, we cannot do that in the beginning. So a doubt may come in your mind. Sir, we can make a PAB triangle and we can find angle A and angle B. And if any of those angles is obtuse, we know vertex lies outside, and then we can solve it using the GC method only. But that method is not recommended, because in the question they have told you to follow a composite track. So our beginning should be assuming that composite sailing is relevant here, and we will make a triangle like this only in two parts. Papa Alpha Vector 1, the second part Papa Bravo Vector 1, showing a composite track. So we will start with this. However, while working out, if we realize that in this question vertex coming outside and composite sailing is not relevant or not required, then we switch over to GC sailing and find out the GC distance. So fundamentally start with composite and then switch over to GC if required. There is a second disadvantage of starting with GC. One is, if you initially start with the GC track and you calculate angle A and B, if both the angles are acute angles, then you will have to switch over to composite and you will be wasting some amount of time. Even if one of the angles becomes obtuse and you follow the GC solution, the examiner will have a doubt in his mind that how did you figure out before solving the question that in this particular question composite sailing was not relevant. Because if a limiting latitude is given in the question, it is considered that you will be starting off with the composite sailing method. But if you straight away start with the GC method, the examiner will be clueless. How did you figure out that composite sailing was not relevant here? So a doubt in his mind may lead to deduction of marks. So start with composite, and if you realize later on that composite sailing is not relevant in this case, move on to GC. Now this could happen in normal composite questions also, where you have three triangles. Here we have only two triangles, but in case you have the third triangle also, the normal questions which we did in composite sailing. Now in that case, how will you come to know if in a particular case composite sailing is not relevant? Now when you are solving a normal composite question having two vertices V1 and V2 and there are three triangles PAV1, PBV2 and a non-spherical triangle in between, that is PV1, V2. So in that case, you need to calculate the middle angle P there. This middle angle P helps us to calculate the rhumb line distance between V1 and V2. So if in any of the questions the middle angle P comes to be negative, remember in those questions we were calculating the complete angle P, which was the D long between initial and final positions. Then we were calculating the smaller angle P of first triangle PAV1 and the smaller angle P of the last triangle PBV2, and we were subtracting these two small angles to get the middle angle P. So if in any of the questions you get a negative middle angle P, so that simply tells you that composite sailing is not relevant or not required in this case. If you follow the GC track, direct GC track from the initial position A to final position B, you will never be crossing the limiting latitude at all. So once it is clear to you, you get a negative angle P, just write a remark there. Since the middle angle P is negative, it indicates that following a GC track from A to B, we are not going to cross the limiting latitude at all. So in this question, the composite sailing is not relevant, hence solving it using a normal GC sailing question. So you make the PAB triangle and find out the GC distance between them straight away. So these are the two out of ordinary kind of questions which may sometimes appear in the exam, though the frequency is very, very low. If the question says it's a composite sailing, 99% it would be a composite sailing question only. But now you know that if you get stuck like this, the vertex comes outside the triangle PAB in a two triangle case, the one like the one which we see on the screen, or the middle angle P comes negative in a normal composite question, you know that composite sailing is not relevant and you switch over to the GC sailing. So this is how we tackle the typical question. So now you can go ahead with your doubts, Peter.
When you said in the first place where composite sailing doesn't matter, when you initially go on a course of A to B, wherein the vertex is beyond B, so the AB becomes a safe track, right? So we can do that by great circle entirely, right?
That's correct, Beta. When you solve this, okay, we will start with composite exactly making the diagram as it is made here on the screen. If you find the vertex going outside, switch over to GC. Just write a remark, composite not applicable here, and switch over to GC.
Okay, so that was one case. And second case, you said that in case if there are three triangles, not like the one where your limiting lat is on the destination latitude. If
Mhm.
this was like the typical problem which we had discussed before, where three triangles are there. So
Mhm.
is there any case where the vertex will go beyond the third triangle also?
No, beta, no. It will not go beyond the triangle in that case. In that case, the middle angle will become negative.
Okay, perfect, cool. So the middle angle will obviously come negative because the two angles will be subsiding over the other one. So in case we find out that the middle angle is negative, then that is automatically like composite scaling does not exist.
That's right. And you switch over to GC.
Okay, sir. Thank you.
Sir, excuse me, sir.
Bolo, beta.
Sir, my question is when we are solving the first triangle PAV1, we will come to know that it is composite or great circle, right, sir?
That's right, beta.
So next step, why we need to calculate the next step that we are getting angle P negative or positive to confirm it is a composite sailing?
No, beta, no. That negative angle is in a three triangle scenario. ओके, टू ट्रायंगल में आपको नेगेटिव एंगल कभी नहीं मिलेगा. टू ट्रायंगल में तो वर्टेक्स बाहर जाएगा और आप जीसी में स्विच ओवर कर लोगे. नेगेटिव केसेस जब तीन ट्रायंगल होंगी बेटा तब बन सकता है.
Okay, so it's possible that the first triangle is a GC track, composite. Second will be rump line, and third can be like I want to say that sir, third triangle को solve करना जरूरी है क्या before to know that it's composite or not?
नहीं बेटा, मैं समझाता हूँ, आप समझो. सबसे पहले तो आपको ये तो पता चल जाएगा कि टू ट्रायंगल वाला क्वेश्चन है या थ्री वाला, पता चल जाएगा ना.
हाँ सर, क्वेश्चन से पता चल जाएगा.
वेरी गुड. अब मान लेते हैं कि टू ट्रायंगल वाला क्वेश्चन है, जैसी डायग्राम आप देख रहे हो. इस केस में वर्टेक्स 1 का लॉन्जिट्यूड हमने निकाला, लॉन्जिट्यूड बाहर आ गया, हमने जीसी में स्विच ओवर कर लिया. क्वेश्चन डन. ओके
ओके सर.
अब आते हैं थ्री ट्रायंगल वाले क्वेश्चन पे. थ्री ट्रायंगल वाला क्वेश्चन आपने सॉल्व करना शुरू किया. जब आपने मिडल एंगल पी निकाला, मिडल एंगल पी नेगेटिव आ गया. जब मिडल एंगल पी नेगेटिव आया, आपने जीसी में स्विच ओवर कर लिया. क्वेश्चन सॉल्व्ड. डन बेटा.
ओके सर, सो अगर नेगेटिव आया पी तो कंप्लीट ए टू बी विल बी लाइक ग्रेट सेलिंग सर, राइट?
दैट इज राइट. कंप्लीट ए टू बी ग्रेट सर्कल सेलिंग, नो composite anywhere.
Okay sir, clear.
Sir, in that question, once we find out that it's no longer a composite sailing question and GC is applicable to GC, then do we need to find out what is as well in that case? Or we can just simply find out GC distance initial to final goal, that's all?
No बेटा, in that case vertex is not required. आपने वैसे फाइंड कर ही लिया है, बट इन दैट केस नॉट रिक्वायर्ड एट ऑल. यू सिंपली स्विच ओवर टू जीसी एंड फाइंड आउट द जीसी डिस्टेंस स्ट्रेट अवे.
So if we have angle P D long with us and we find out the P1, that is small angle in PAV1 triangle, and if it comes negative, then already this vertex is not lying inside the our track. So then we directly know that it's not lying inside our track.
बेटा आप इसी क्वेश्चन की बात कर रहे हो जिसकी डायग्राम है बनी हुई?
यस सर, इसी की बात कर रहा हूँ मैं.
ओके बेटा, इस केस में कभी भी आपका एंगल पी नेगेटिव नहीं आएगा.
ओके सर.
You will always have a positive angle P when you apply the Napier's. So you just check the longitude of the vertex. Longitude will tell you whether it lies inside or outside.
सर अगर डी लॉन्ग से बड़ा होगा एंगल पी हमारा तो वो ऑटोमेटिकली बाहर जाएगा.
हाँ बेटा, बाहर ही जाएगा, नेगेटिव कभी नहीं आएगा एंगल पी इस केस में.
हाँ सर, अगर डी लॉन्ग से बड़ा होगा तो देन वी डोंट हैव टू कैलकुलेट द लॉन्गिट्यूड ऑफ एंगल V1.
राइट बेटा, राइट, दैट इज राइट.
ओके, थैंक यू सर.
राइट. और बताओ बेटा, और क्या डाउट आ रहे हैं?
Sir, just one thing, I'm sure everyone will also might agree to this. So possibly you can give a dictation on this 2 points what we discussed just now, so that we can write it down. It can be clear in case it it is asked in the exam.
ओके बेटा, ऑल राइट. आपने व्हाट्सएप ग्रुप पे शेयर किया है?
Yeah, it's there on the WhatsApp. So can you give a dictation, like we can note down or something?
Okay, all right. Let me check, beta. Shall I remove the screen?
Yes, sir. Thank you.
Okay, just a minute. Okay. Okay, you mean to say कि अगर हमारा ये typical question आता है and the vertex goes outside, what is to be written in remarks? That is what you want to be dictated, right?
Yes, sir. That's right. Yeah.
Okay, I'll do that, beta. It is very simple. Don't bother about anything. When you get the vertex outside or you get a negative angle, you just write composite sailing not applicable, switching over to GC. This one remark is enough.
Okay.
Okay. Okay, beta. All right. Okay. So any more doubts coming in, beta? Very good. That's great. So with this, we complete our great circle sailing and composite sailing topic. अब आप बेटा जो मैंने असाइनमेंट आपको भेजी थी वो असाइनमेंट पूरी कंप्लीट कर सकते हो. All the questions you should be able to do them. So please practice all those questions in the assignment. And once you complete that assignment, that should prepare you for question number 4 of your paper. Once the assignment is done, assignment आपने कर ली, आपकी तसल्ली हो गई, you are confident and comfortable, you can go to any past paper, pick up question number 4, you should be able to do that.
Sir, can you please share assignment again, sir?
I'll post it on the group, beta. No issues. I'll post it again on the WhatsApp group.
चलो सर 25 नंबर हो गए.
25 marks आ गए बेटा.
Thank
Okay.
you so much, sir.
So
This is the
make
case,
sure
very nice.
but make sure that you complete the assignment. Okay. So that will give you sufficient practice.
Sir, can you share the PPT for these two conditions that you just told us?
115 और लाने सर.
लाएंगे बेटा, लाएंगे, वो भी लाएंगे. Just a minute, let me share the assignment with you once again. ये मैंने आपके ग्रुप पे बेटा वापस से शेयर कर दी है for those who did not get it.
So you'll be sharing this presentation as well?
Why do you need the PPT?
No, I think somebody asked this now. That's right.
He's planning to start his own YouTube channel.
Why you need the PPT?
Sir, just for the revision purpose, maybe after 1.5 months we might forget the special condition.
Public मांग
You can revise it.
No problem. I'll
Only
share
for
with
the-
you. मैं screenshot share कर देता हूँ बेटा आपके साथ. So let me. I'll share it just now. Don't worry.
PPT लेके सर अपनी क्लास चालू करेगा.
No issues बेटा.
लेकिन सर जो कंपोजिट सेलिंग का होगा बहुत इजी हो गया. वो बहुत ज्यादा था कि कंपोजिट सेलिंग है. नाउ इट बिकम इजियर सर.
Yes, sir. Very nice. Thank you, sir. Thank you so much. Very nice.
Okay, that's great beta. Basically intention is that you should be able to understand it easily and पेपर में देखो जो प्रॉब्लम होती है वो ये नहीं होती कि आप क्वेश्चन नहीं कर पाते. पेपर में क्या होता है आपके ऊपर टाइम प्रेशर और एक्यूरेसी प्रेशर होता है. सो इन टाइम प्रेशर आप वही मेथड करेक्टली कर पाओगे जो इजी है, जिसे आप इजीली अंडरस्टैंड कर सकते हो. So you should be able to understand it very, very easily, and then there should be no problem in getting to the solution. So let me share a screenshot with you of this question. Give me a minute.
सर आपकी क्लास करने के बाद पता लग रहा है, पता नहीं कैसे सेकंड मिड क्लियर किया था, उसमें जीसी था, बस ऐसे ही अपनी मर्जी से जो समझ में आया सीख लिया था।
सेकेंड मिड के टाइम पे भाई बस ओरल था।
I think second mid did not have composite sailing, it had only great support.
नहीं, जीसी की बात कर रहा हूँ।
हाँ, correct.
अच्छा, नहीं था क्या सेकंड मिड में ये कंपोजिट?
No, second mids never had composite, only GC.
ये लो बेटा, मैंने शेयर कर दिया है व्हाट्सएप ग्रुप पे ये टिपिकल क्वेश्चन वाला जो प्रेजेंटेशन था, सो यू कैन, इफ यू वांट, यू कैन जस्ट रिवाइज इट फ्रॉम देयर। ओके, अब बेटा आगे हमारा अब ये ग्रेट सर्कल और कॉम्पोजिट, ये दो टॉपिक कवर हो गए हैं। नाउ वी आर मूविंग इनटू प्रैक्टिकल नेविगेशन। ओके, सो प्रैकनैव में मैं बिल्कुल बेसिक से शुरू करूंगा। हो सकता है आपको थोड़ा बोरिंग भी लगे, हो सकता है नींद भी आ जाए, because I want to go through the basics of plane and parallel sailing as well as Mercator sailing and then we will move ahead. हमारा जो आगे प्लान रहेगा, plane and parallel sailing, Mercator sailing and then celestial navigation. Celestial navigation में मैं बिल्कुल basics, again I will go to the basics, familiarization with the almanac, what all information is there. फिर आपकी जो basic calculations है ना, calculation of amplitude, calculation of azimuth, ओके, गेटिंग द कंपास एरर, ये सारी चीज़ें, एल्टीट्यूड करेक्शन, ये सारी चीज़ें हमने एक बार टच करनी है। सो सम ऑफ यू मे इवन फील बोर्ड कि ये हम पुराना सेकंड मिड का टॉपिक दोबारा रिवाइज कर रहे हैं, बट लेट इट बी, आई वांट टू स्पेंड दैट मच ऑफ टाइम, बिकॉज अगर ये चीज़ आपके माइंड में क्लियर नहीं है एंड यू मेक ए मिस्टेक इन दीज, तो बड़े क्वेश्चन तो ऑब्वियसली गलत हो जाएंगे। ओके, सो ये हमारा प्लान है। अब बेटा हमारे पास दो ऑप्शन हैं। One, we can jump into plane and parallel sailing now. It will take about half an hour, 45 minutes, or we can do it in tomorrow's class also. I have a class with you tomorrow.
हाँ सर, वो ट्रेन थी
संडे भी सर।
So shall I continue?
ट्रेन थी सर, ट्रेन एक बंदे की ट्रेन थी ना सर।
कल करते हैं सर, आज संडे भी है सर।
ट्रेन कितनी स्पीड से चल रही है?
ठीक है बेटा, ओके।
पहले
सर ये ग्रेड सर्कल का क्वेश्चन पहले कर रहा था सर, इसमें ये कोसाइन फॉर्मूला ना, यहाँ पे माइनस होता है, जैसे कोस ए बी माइनस हम साइड से लेते हैं, वहां पे प्लस था एक जगह पे, तो मैंने हैंड आउट से देख रहा था, मेरे को समझ नहीं आया, लेकिन फिर मैंने